The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to suicidal steady state analysis. The question is numbered 26. As per the question, there is a AC circuit given which contains a voltage source Vs and some resistors of resistances 2 kilo ohms and 1 kilo ohm and inductances 100 millihenry and a capacitance 10 microfarad and another resistance 1 kilo ohm. It's given that Vs is equal to 60 multiplied by cos 200t minus 10 degrees volts. We need to find the current I of t delivered by the source. For finding the current I of t delivered by the source, we see that the circuit is operating at 200 radians per second. By converting the given circuit to phasor form, we can redraw it as shown, and the voltage is Vs, which can be further written as 60 phase minus 10 degrees. Here we are considering the peak values, and the 100 millihenry can be written as j omega L. So on substitution, we see here omega is 200 radians per second and L is 100 millihenry. So on substitution, the impedance becomes J20 ohms. Similarly, the impedance corresponding to 1 by j omega c becomes minus J500 ohms, and the resistor is of 1000 ohms. Now, by, do, by reducing the network to smaller form, first we see that these two impedances are in parallel, and on reduction, we see that the equivalent impedance is 200 minus J 400 ohms. Now, this is in series with J20 ohms. So, the equivalent impedance can be written as 200 minus J 380 ohms. Now, we see that this impedance is in parallel with 1000 ohms. So, the equivalent impedance can further be reduced as 242.62 minus J 239.84 ohms, which is in further in series with 2000 ohms. From this, the total impedance Z can be written as 2242.62 minus J 239.84 ohms, which can also be written as 2255, sorry, minus at a phase of minus 6.104 degrees. So, in phasor form, the current delivered by the source is Vs divided by Z, which can be written as 60 phase minus 10 degrees divided by 2255 at a phase of minus 6.104 degrees. This finally becomes 26.62 at a phase of minus 3.896 degrees milliampere. In time domain form, the current delivered by the source I of t can be written as 26.62 cos 200t minus 3.896 degrees milliampere. From the given options, we see that the correct option is